Okay, number 12. We have a fraction that's on the inside of the parentheses and then an exponent on the outside. Now in the order of operations, it does say to do what's in the parentheses first, and so if there's anything I can do in the parentheses, I should do that first before doing the exponent. So in this case, I have a negative 4 on top, but there's no other coefficient on the bottom, so that's going to give me negative 4. Then I have a cubed over a squared, so that would give me a to the power of 3 minus 2. And then I have b squared over b to the fourth, and that would give me b to the power of 2 minus 4. Because remember our division rule, that if we are dividing the variables, we need to subtract the top exponent minus the bottom exponent. So we have a negative 4, and then a to the power of 3 minus 2, and b to the power of 2 minus 4. So this gives me negative 4. A to the power of 3 minus 2 would be just a to the power of 1. And b to the power of 2 minus 4 would give me b to the power of negative 2. Now remember that when you have a negative exponent, this needs to go to the bottom part of the fraction. And so we should have negative 4a over b squared. Then, after we've done what's on the inside of the fraction, then we can bring the exponent. We need to remember to bring this exponent to each part of this problem, including the bottom part. So including this b squared, also including this negative 4. So this would be negative 4 to the power of 4. Don't forget to put the negative coefficients in parentheses. Then a to the power of, when we bring in this exponent, we multiply it times the exponents of the variables. So this is a to the power of 1. We're going to multiply that times 4. A to the power of 1 times 4. And then on the bottom, we need to multiply this 4 times the exponent 2, b to the power of 2 times 4. And negative 4 to the power of 4, that would give me 256. A to the power of 1 times 4. 1 times 4 is 4, so that's a to the fourth. And on the bottom, b to the power of 2 times 4. 2 times 4 is 8, so b to the power of 8. Okay, so another way that you can solve this same problem is that you could start by taking this exponent of 4 to everything that's on the inside. So we can take this 4 to the negative 4, to the a to the third, the b squared, the a squared on the bottom, and the b to the fourth on the bottom. Now I prefer to do this other way from video 1 for this problem, but it is possible to solve this other way. So this would give me negative 4 to the power of 4, a to the power of 3 times 4, because when I bring in this 4, this exponent from the outside, I multiply it times the exponents on the inside. So a to the power of 3 times 4, and then b to the power of 2 times 4, all over a to the power of 2 times 4, and b to the power of 4 times 4. From there, we would have negative 4 to the power of 4, that is 256. A to the power of 3 times 4 would be a to the 12th. B to the power of 2 times 4 would be b to the 8th. All over a to the power of 2 times 4 is a to the 8th. And b to the power of 4 times 4 is b to the 16th. Then we do our division rule, which says that when we are dividing variables together, we are going to subtract the exponent, the top exponent minus the bottom exponent. So we'd have 256, and then a to the power of 12 minus 8. 12 minus 8 is 4. And then we'd have b to the power of 8 divided by b to the power of 16. So we do 8 minus 16. That is negative 8. And so since it's a negative, that should go on the bottom. So we have a b to the 8th on the bottom. So either one of these is a fine way to solve it. I prefer to solve it this way, but this way is fine as well.